We probably hear a very famous story about the eminent scientist, Sir Isaac Newton, who was hit on his head by an apple that fell from a tree. Legend had it that this enlightened him to formulate the law of gravity. This famous story was far from true, however, and no written evidence has been published to support such event. Historical accounts state that upon Newton's return to Cambridge to escape the bubonic plague in 1667, he witnessed an apple from a tree while in an orchard, and this prompted him to contemplate about the true nature of force and how it causes motion. This module begins the long yet rewarding journey to explore the marvelous physics behind force and motion. We can remember from our previous science lessons that force refers to the pull or push exerted upon an object as it interacts with another object. Simply put, force is the cause of interaction between objects. We also considered force as a vector quantity consisting of a magnitude and a direction. The two figures you see in your screen show that the force is resulted from the interaction of objects. The vector F is distinguished according to first, its magnitude or the amount of strength of the push or pull, and second, its direction. The magnitude of force is also expressed by the SI unit Newton. Moreover, the most typical instrument used to measure the magnitude of force is the spring balance. There are two types of forces, contact force and non-contact force. From the names of these forces, can you name their correct definition? That is correct. The interaction that brings about a direct physical contact between two objects is caused by what is called contact force. There are three major kinds of contact forces. First, we have normal force, which refers to the force exerted upon an object by the surface with which it is in contact with, as shown in this figure. You will notice that the normal force is perpendicular to the surface, regardless of the angle of object. The next type of force is the friction force. With your knowledge of friction force, which illustration do you think correctly represents the friction force? Correct. Since friction force refers to the parallel force exerted upon an object by a surface, we can illustrate it as something against the direction of the object. The last type of contact force is tension force, which we can symbolize as big letter T, and refers to the pulling force exerted upon an object by a cord it is attached to. Aside from these three major kinds of contact forces, there are other types of forces like air resistance, applied force, and spring force. Air resistance is a force opposite to the relative motion of the object as it moves through the air. Applied force is a force applied to an object by a person or another object. And the spring force, and sometimes we call it as restoring force, is a force exerted by a compressed or stretched spring to an object. In contrast to contact forces, there are also non-contact forces, which are also referred to as long-range or action at a distance forces. These forces act between objects that are distant and are separated by a vacant space. Example of non-contact force includes first, magnetic force, which is responsible for the repulsion or attraction between moving charged particles. We also have electric force, which is the force exerted by one electric charge to another, both for stationary and moving charges. And lastly, gravitational force, which refers to the force responsible for attracting two objects that have mass or the amount of matter available in an object. We need to distinguish this from weight, which is a gravitational force exerted upon an object. Gravity is directly proportional to mass and inversely proportional to the square of the separation distance between two. Aside from contact and non-contact forces, we also have fundamental forces. These forces are found in nature and classified as field or non-contact forces. In order of decreasing order, the fundamental forces are the following. First, strong nuclear force, which keeps the atoms from separating together due to the electric force from the repulsion of the protons. Second, electromagnetic force, which exists between electric charges and can be attractive or repulsive. It explains the interaction between moving and static charges. These forces also act at extremely large distances. Next, we have weak nuclear force, which is found in radioactive processes. This type of force is responsible for the nuclear reactions that generate the sun's energy output. And lastly, gravitational force, which is the force responsible for attracting two objects with mass. In astronomical systems, it determines the motion of the moons, planets, stars, and galaxies. It also affects the nature of time and space. In the next lecture, we will talk about how these forces are illustrated as free body diagrams in order for us to unfold the concepts behind Newton's findings on motion and gravitation. That is all for this lecture. I am Gilmar de Castro, and see you in the next video.